Welcome to yet another exciting educational video brought to you by Upvision Concepts Academy. So today we go ahead with the part 2 of the series, JAMB style questions on logarithms, surds, sets, and Venn diagram. So we'll continue where we left off in part 1. Now looking at a question from surds, it says simplify 3 root 2 plus 4 root 2. These are known as surds because they have root function numbers in them. So these are the options you are given to pick from in the JAMB. And by expression, you see that this root 2 and this root 2 are the same thing. So if you have the knowledge of algebra, you can treat this like that. And when you have the similar sort numbers, you just take the coefficient, that's the number before them, as something you can operate on, either by addition or subtraction, depending on the operation you have there. So if we say take root 2 to be a, for instance, in algebra, you know that in algebra, 3a plus 4a, as you have here, is 3 plus 4, 7a, right? Why? Because the a is constant. So in the same vein, I'm taking this root 2 as an algebra, something that I can hold together, together. So I have 3 root 2 plus 4 root 2 is the same thing as adding this and this. 3 plus 4 is 7, then retaining the root 2. So the answer is A. This is very simple. Just know your background should be the knowledge of algebra. Okay? So this question is similar to what we just did earlier. 5 root 5 minus 2 root 5. Again, you know that root 5 root 5 is the same thing. So I can just work on the coefficient. These are the coefficients. Number before the surd. Okay, so 5 minus 3 here. 5 minus 2 here is 3 root 5. Already the answer is gotten as B. A, sorry. A, please. Okay? Okay, so we have this. Calculate root 3 times root 12. Okay, so now because we don't have them in the same base, I can make this one to be the same base as this, or the same root as this. So I express this as its factors. I'll write the question again. I say root 3 times, instead of writing root 12, I will say root 3 again times root 4. Why? Because root 4 times 3 will give me root 12, right? So I have something like this. So these two can collapse to give me just 3. And this one can you can find the square root of this one to be 2. So I told you in the previous I said root a times root a times root a is equals to a. Root b times root b is equals to b. Root c times root c is equals to c. You get the point now. So root 3 times root 3 is what? 3. So this 2 give me 3 times this one gives me 2. Why? Because root 4 is 2. So 2 times 3 is 6. So the answer should be one of the options. A is the answer. Okay, so number 14 here says simplify root 50 over root 2. Again, I can do this simple fractions. Root 50 is the same thing as saying root 25 times root 2. And which will go on to give us root 25 is 5 times root 2 or 5 root 2. So this numerator is this one. Therefore, root 50 over root 2 is the same thing as the simplified form is 5 root 2 over root 2. Root 2 can cancel root 2. Answer is 5. So the option here is A again. Okay, so see a possible JAMB question for this year. Let U, this under set. So we are done with this, and now we are in set. So let U be all this 1, 2, 3, 4, 5, 6. You know, a set is just numbers in ordered form. You have two curly brackets, bounding them, and they are specified by a comma sign. They are demarcated by a comma sign. Everything here inside this thing, they are called elements. So one is an element of this universal set, and so on. So I have 1, 2, 3, 4, 5, 6. These are 6 elements in this universal set. U is universal set. And A is a subset of U. Why? Because everything inside of A inside of U. Let's go. Let's check. There's 2 inside of A, set A. 2 elements. Element 2 is inside set A. And this element 2 is also inside this universal set. So that means this and this correlate. 4 is inside of A, and 4 is also universal set. And 6 inside of A, and 6 is also universal set. That means this one is a subset of this one. But the question says, what is A complement? A complement means what I have in A. That what is in universal set and not in A. Everything that is not in A, but in the universal set. Okay, so let me define it. A complement are elements in the universal set, that is U, but not in A. So having gotten the definition, let's look for everything that is here that is not here. Okay, so A complement is equals to, I have one here, but I don't have one here. So this is the first element of this set. This set is defined by A complement. Okay, I have 2 here, I have 2 here, it doesn't qualify. I have 3 here, I don't have 3 here. So 3 is also a member of this set. I have 4 here, I have 4 here, it doesn't qualify. I have 5 here, I don't have 5 here. So that means 5 is part of this set. And I have 6, I don't have 6. So this is where it closes. So this is the answer for this particular question. So the option is A as well. So I have another question on the board on sets. So if A is defined as elements 1 and 3, B is 3 and 5, find A union B. So A union B is defined as, in plain English, elements present in set A and set B without repeating them, without repetition. So I'm not going to be repeating anything that's already there in both. Okay, so I'm going to do A union B now. A union B is equals to, so I will look at what is in A and what is in B, and I'll mention it once. That's for union. So I have 1 here, and I don't have 1 here, but I have 1 at least in one of them. So I mention 1. I have 3 here, I have 3 here. I'll mention it once. I will not say 3 and 3. So I'll just mention it once. And I have 5 here. I don't have 5 here, so I'll mention it once. So this is A union B. So the option here is C as the answer. Okay, so 17, JAMB style question, possible question for this year. Say if A is equals to 2, 4, 6, that's elements 2, 4, 6. These elements are present inside of A. And B, I have element 4, 6, 8. What is A intersect B? List the set. So A intersect B is pronounced as, let me put it in writing, as A intersects B, right? And is defined as elements, is defined as a list of elements in both sets. So I'll mention them once. So for this case, A intersect B is, so I look at this one, I have 2 here, I don't have 2 here, so it doesn't qualify as intersect. I have 4 here, I have 4 here. So the first element in the intersect set is 4, right? Comma, I have 6 here, I have 6 here. So another element is 6. I don't have 8 here, I have 8 here. So that ends the list of elements. So A intersect B is just simply 4 and 6. The answer is option B. So this question says U, which is universal set, is defined as elements 1, 2, 3, 4. A is defined as set with elements 2 and 3. B is defined as set with element 3 and 4. Mind you, A and B are subsets of U. Why? Because every element in A is present in U. Every element in B is also present in U. So the question here says A difference B. This is read as difference in set notation. Read as difference, not minus. But it has the same connotation with minus. I will explain it. So if I say A difference B, it means that what is in A but not in B. So elements in A, not in B. Let me repeat on the board. A difference B is A difference B. It means elements in A and not in B. Okay, so this is A. Is element in A, not in B. So we'll start from A as a reference. So I have 2 is in A, not in B. 3 is in A and it's in B, so it doesn't qualify. So the only element in A, not in B, is 2. So therefore, A difference B is 2. Mind you, the solution to this is also a set. Let's say there are more than these 2 that I'm putting here. I will list them. But I only have one. This set has only one element. This set, A difference B, has only one element. And the element of A difference B is U. Okay. So we have on the board U universal set is 1 to 10. That is, they put it 1, then continuous dot to 10. Meaning that every element in this set is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Remember, separated by commas, right? Now, A is 1, 3, 5, 7, 9. These are elements of A. And everything inside of A is inside of universal set. So therefore, A is a subset of universal set, right? Then B is given as 5, 6, 7, 8. The question is, what is A intersect B? That is, A intersect B is what? So A intersect B is actually a set of elements. But let us find those elements. Remember that I said that A intersect B means that everything inside of A are the same time inside of B without repetition. You don't have to repeat them. Okay, so I start from there, compare. I have 1 here, I don't have 1 here. So it's not a member of this new set, intersect. You understand? I have 3 here, I don't have 3 here. It's not a member of this new set. I have 5 here, I have 5 here. So it means that the first element of this new set is a 5. I have 7 here, I have 7 here. The next one is a 7. I have 6 here, I don't have 6 here. I have 8 here, I don't have 8 here. I have 9 here, I don't have 9 here. So this is the end of the series of elements. So A intersect B is just simply 5 and 7. So the option here is B. I hope you enjoyed today's video. We'll wrap it up today on this note. Kindly subscribe to our channel if you have to subscribe to get more exciting videos. And stay tuned because we're going to be treating a lot of JAMB questions. This is the season of JAMB. And if you like what we are doing, also share to your friends. Thank you for viewing.